Good afternoon, ladies and gentlemen. Well, actually, I have been forced from my boss that I have to give a talk on something which is possibly related or not related to this kind of theme. So when I'm thinking the first time and I sent all the slides to the committee, what I end up is this kind of things. Seismic hazard analysis in Thailand and news analysis. The problem is probably not much related to this theme at all, so I have to change my talk a little bit, which is more attractive, is more concerned about this kind of theme. So I have to make it synchronized with the theme as much as possible, which actually is not that my experience, and particularly end up with so what should I say? So I think in the last minute that I should change my talk to something which concerned about the cause of the climate change, the global warming or the global cooling. And the last one is how important is something which I involve is going to be. Actually, my research unit is a kind of tectonic earthquake and tectonic geology. So when I'm thinking about it for a little while, and I say that, well, actually, what should I say here is the climate change due to what? What caused the climate change? So when I look at these morning sessions, and what happened is people talking about human activity. Is there any natural activity which concern about climate change? Or this is because of the combination of these two? Since because I am in the earthquake and tectonic geology research unit, so I have to mention clearly that I would like to mention about the natural cause and the actually from the tectonic movement. So what I feel really concerned is so correct me if I'm wrong. The whole earth is now cooling and not warming in the long term, believe it or not. So when people talking about the global warming, then we say that, well, it's because of the ice melt at the Earth pole and because of we have increased the sea level. What's going to happen is the coastal erosion, modification of landform. This is a very interesting issue. If we look in the past for 450 million years ago, so what happened to the Earth is at that time, the Earth is what? Very hot. If you do believe that, then it seems to be something which we involve right now is the Earth is cooling. So what we face as present is right at the surface of the Earth only, not inside the Earth. So the Earth is cooling down. So what happened next? And where is the Earth cooling down? Because the Earth would like or really want to cooling down. So the most important natural causes at present is the tectonic activity can play a very important, very crucial role in the climate change. Actually, for human activity, maybe it's possible to cope with if we can get a very good cooperation for each country in the world. However, for tectonics, for natural cause, it's quite impossible to get a very good cooperation. But we have to cope with this. This is the past. The left slide is from at least 200 million years ago. But the right one is the present day. So what happened to the old days, long time ago, is this something like this. All the continent seems to be put together like this. And what happened to the middle of the continents right here is quite cold. Right over here is also cold. Right over here is warm. But at that time, the earth is like this. Circulation of seawater is not the same as the present days. So what happened is it's quite dissimilar from this and this. So that means that we have these affect more land at higher latitudes for sure. Outer ocean currents and heat transport may have been taken place for sure. Atmospheric circulation changed. And what happened is something like this. So we think about more glaciers over land and something like that. Cooler temperatures may have been taken place. Something which is like this is quite more concerned. We have to realize that plate movement also generated more and more volcanic activity, particularly at present. And hence the plate is interact like this. What happened is magmatism, volcanism produce more carbon dioxide, and this will change the global temperature to become riser and riser. So what happens if there is little movement of the plate? Volcanic activity decreases for sure. Oops, sorry. And the carbon dioxide concentration become lower in the atmosphere, and the temperature decrease. Do we want something like this? Do we want to have the plate movement? If there is no plate movement, we will not stay like on here at the surface of the earth. We now know that from our cluster that so many kind of the types of the hazard. Some of them are natural hazard which can cause the flood, can cause cyclone, drought, landslide, something like that. But if we have something climate change, then sea level become riser, salinity intrusion become higher. But what happens if we got extreme climate change? We have earthquake, we have tsunami, we have all kind of these things. So we have to at least know how to cope or how to understand this particular natural phenomena. This is a kind of slide which telling you that here we have the mountain right over here, we have sea right over here, and rain coming up over here to the hill and become drier and drier. So we get rain shadow. We know for this for sure. But if we look at this one, of course, this is an example from Himalayas. We all know that when the India collide with the Asia continent, what happened is the generation of Himalaya range. And what happened, as you can see from this slide, is that the northern part of the Himalaya become cooler and cooler. And next one is the Tibetan plateau, then end up with the Gobi desert. And this is the real thing. Interaction of the continent may have caused a very drastic climate change in the long term. Another interesting is something like this. What we want is the inorganic carbon cycle. So what we can get from here is a kind of plate interaction. The continent of the ocean lithocephalic plate subduct beneath the continental plate. What happens is we can produce more carbon dioxide, and then what happens is we can produce calcium carbonate. We can produce something which is called calcium silicate plus carbon dioxide. We get more carbon dioxide, and then we can produce something like calcium to the seawater. Something like this happen, and then what happened is not related to this one, but what would like to mention here is a kind of the interaction from the outside or extraterrestrial phenomena, that the climate change can be due to variation in the Earth orbit itself. And for every 100,000 years, what we get is the ice coverage for the whole Earth, particularly at the pole. It is true based on the fossil data. We realize very well that there is something like this occur in the past for sure. The warping of the Earth axis may have caused a kind of particular change in terms of climate as well. I don't want to go into detail for this, but what I really want to mention here is this kind of tectonic activity which we have realized in the past that these have caused the aerosol which reflect and absorb the shortwave radiation. So as a result, the aerosol can produce warming in the stratosphere, and of course cooling in the troposphere. Recent data, particularly for the significant eruption of the Chichon in Mexico, tell us something about the higher temperature, particularly climate change due to the volcanic eruption in Pinatubo in Philippines. And what happened is the stratosphere is, you have to remember that stratosphere is a very stable layer. It's difficult to disturb unless there are some aerosol from the volcanic activity. Gases come out from the volcanic eruption. Then aerosol will have a very long residence time in the stratosphere. And this may have caused higher temperature. Can we control it? Another one is precision cycle. Actually, I don't want to make into details. This one is what happened for Pinatubo plume, producing much more sulfur dioxide. And this is the what happened from what scientists believe is inject 20 million tons of sulfur dioxide into the atmosphere, or that means stratosphere. Sulfur dioxide was observed around the globe, particularly along the equator. And this may have ended up with the, thank you for the higher temperature. I will finish very, very soon. Sorry. What happened is the temperature will become something like this. It's quite changed, and the temperature dropped for 1 or 3 years. So actually, we now know that how important to understand the tectonic activity. In order to understand the climate change, we need to know something which is more natural phenomena too. Then we can cope up with these things that what we are now trying to mention, or what I'm like to mention here, is not only the human activity can give rise to the climate change. All human activity can accelerate the climate change. Climate already changed in the past time. until at present. But actually human activity accelerates the higher the temperature of the surface of the Earth, the surface of the Earth only. That's my talk. Thank you.